Hello everyone, today we are solving another question. The question is combinations. What is the problem statement? We are given as two integers n and k. We are given as two integers n and k, and we have to return all the subsets which contains k elements from the array of 1 to n. For example, in this case n is equals to 4, so we have an array of 1 to 4, and now we have to return all the subsets which contain two elements. That means, or you can say all the combinations which contains two elements, like for 1 2 1 3 1 4 2 3 2 4 and 3 4. So you can see all the combinations we have to return. So how to approach this question? So since all possible combinations, all possible permutations, yeah, all possible terms, when we used to hear all possible terms in a problem, we suddenly get an idea of recursion or backtracking. So yes, this is a problem of backtracking. Let's see how we can solve it. So we have 1 2 3 4, we have this array. Now we have to take out the elements. How we can take? So let's say we are taking first element as 1, and here k is 2. Now since we had taken first one element, we'll drop down it to 1, and the rest of the array will be 2 3 and 4. Okay, now from this we'll again take 2. Now k will become 0, rest of the elements are 3 and 4. So since should we take another one element 1 2 and 3? No, because why? Because k has become 0. Now we cannot decrease k more, k cannot be become -1. So we'll backtrack and we'll see. We'll take another element, like we'll take 2. We'll move from this index to this, and we'll take 2. Rest of the elements will be 1 3 and 4. In fact 3 and 4, because we'll traverse in this direction, so only these two elements will be remaining, and k equals to 1. And next again we'll add one more element, so 2 and 3. 2 and 3, k will become to 0. Now I have backtracked to this and to this also. To the parent, to this array I have backtracked. So for like if I'm using backtracking, so it will backtrack in it for this way also. For this branch it will also backtrack. So once you have taken 2, so it will take 3, and again k will become 0. Similarly it will take 4. So see, this and this, we are getting an answer. And similarly when you will backtrack this, so you will again get 2 and 4. So this and this we are getting, and the third branch will be again 3 4. We'll take 3, and then next element is this, so we'll take 3 and 4. So from here we'll get another answer. So this is somehow the backtracking tree will look like. So let's write the pseudocode. So what thought you are getting? So from the backtracking tree, I am getting the thought that whenever k is becoming 0, we are getting an answer. So base case will be what? If k is equals to 0, we are getting an answer. So result dot pushback answer. We are getting an answer and just return. Okay. If we are not getting an answer, what we are doing? We are adding one elements and then decreasing the value. So okay, for I equals index, and I less than k, less than n is size, and I plus plus, and what we are doing? Answer dot pushback. What you have to push back? Array of I, just push back, and again apply solve on I plus 1 and k minus 1. Decrease k and increase I. And why it is I plus 1? Why not index plus 1? Because see, we are traversing in this way. Let me explain it. 1 2 3 4. Index is here. We are traversing in this direction. So when index and I both are here, we have to look this array, sub array. When I is on here, when I is here and index is here, for first index is here, but we are traversing through this, like this branch. For this branch, I will, where I will point, for this branch I will be here. And so for next, for 3, where we have to put, we have to put we have to take 3, so we have to make I point on 3, है ना. Index will be here, I will be here when we are choosing 2. So to choose 3, we have to make I plus 1. Similarly here, index will be on 2, index will be on 2, and I will be on 1 when we are choosing 1. So so for making choose 3, just a second, one will I will be on 3, because we are using this sub array na. So I will be on 3, so 2 3 will become 2 3 will become one answer. So for choosing 4, we have to make it I plus 1, not index plus 1, because if you'll make index plus 1, it will jump off to this answer 3. But this is an separate tree. When this loop will end, it will automatically go to this tree. I hope you got my point, what I said. And for backtracking logic, answer dot pop back. Yeah, this much should be the code. Let's try and write it. Let's see if it is working. So yeah, I'm writing it here on code 360. You can write it on Leetcode also. So we have to return a vector int answer. Let me call it as result, because I need answer also, no? Result. Now vector int answer. So vector int answer. Now let's use a solve function which will take index I starting with 0 and k and result and answer, and what when we'll return result. Okay, now let us add the void solve function. Void solve will give vector. First we are giving it index. So int index comma vector int, and we have to pass it by reference so that changes occur in the result and not in the copy. Okay, and again answer. So vector int answer. I hope you're getting. Now base case, if k is equals to 0, what we have to do, result dot push back what answer and return. Okay, now for int I equals 0, I less than, I have to pass n also, na, for array 1 to n. So okay, no problem, we'll make an array of size, let me call it as a of size n initializing with 0, and we'll pass this, no, not initializing with 0, no, we have to make an array from 1. Okay, so we'll make will for int I equals 1, I less than n, I plus plus a dot push back I. So this will make an array and we'll pass a also. Here also we'll pass vector int a. For int I, a dot size, which is n only, a dot size, and I plus plus answer dot pushback. It will not start from 0, it will start from index, okay, because we need rest of the elements. Like if when we are choosing, like let's say this is array 1 2 3 is array, so when we are at 1, we have to loop it from 2 to 3, not 1 2 3, okay. For that reason it is index. So answer dot pushback a of I, again call solve function on index will be I plus 1. Why I plus 1? Why not index plus 1? I have explained to you. And result comma answer comma a. We are not passing k anywhere, na? We are to pass k also, int k. Oh sorry, k. Oh, we are passing, we have not written it here. Okay, int k. So before result, just k minus 1. And for backtracking logic, will pop, okay. So answer dot pop back. I think this should run. Let's try and run this code. No, some compilation error. What? Okay. This and this. Okay, now it is giving some wrong answer. Output is 0001. Why it is giving a wrong answer? I think this part when we are making an array, this is, I think, little bit fishy. I am saying, since we have to choose 1 to n, so we cannot, we can skip using this. We can directly pass n, int n. We can directly pass n, and n will start from 1. Okay, when will start from? Oh, just a second. We can directly pass n. Why? And int comma int n. Okay, now what we have to we should change first. This should be n plus 1 or less than equal to n, you can say. Not a of I, we have to give index. Fine, because index will start from 1. Index will start from 1. Okay, now let's see, because I have passed index 0, so shouldn't be index plus 1. Yeah, that's the problem. So let's just pass it. Let's pass 1. Why to give 0? Let's see. Again, compilation failed. Why? Because I haven't passed n here. Sorry, the code part is taking so much time, but I am also learning. Could not convert n from okay. Because I have to remove a. I have to remove a. Here I removed a. Here also I want to remove a because I don't need a anymore. Let's see if it runs. Again, it has given me the wrong answer. Why it has given wrong answer? Let's analyze again. Okay, why should pass I now? Because I will start from index and will go to n. So 1, 2, 3, 4 because index is starting from 1. So yes, I have to pass I, not 1. Yes, now it has run. Let's see if this. Yeah. So this was the code part. I made so much mistakes, but finally I got the right code, and I have explained you the code. I hope you got it. Thank you.